The 2086 CC 7-cylinder radial engine, built by engineer Arnold Demand, showcases impressive ingenuity and craftsmanship. Using only components from an air-cooled Volkswagen Flat 4 engine, he reconfigured a car engine into a fully functional radial layout. Originally designed for a Flat 4 configuration, the VW cylinders were rearranged radially around a custom crankshaft, forming a 7-cylinder design similar to classic aircraft engines. While pistons and key parts were reused, the crankshaft and housing required extensive custom machining. The engine displaces 2.068 cc, weighs just 80 kilograms, and uses a dual lubrication system, pressurized oil for the crankshaft and bearings, and a total loss system for the valve train, echoing vintage aircraft designs. Transforming a Flat 4 into a radial engine demanded not just mechanical knowledge, but creative engineering. Demand had to invent new interfaces and adapt each component for a layout never intended by the original VW design. More than a mechanical project, this engine is a tribute to innovation, proving how standard automotive parts can be reborn as a lightweight, smooth-running radial masterpiece through precision and vision. The 1939 Lister Junior A23 is a classic single-cylinder, 3.5 horsepower stationary engine made by R.A. Lister & Company, limited in Gloucestershire, England. Designed for light to medium-duty farm and workshop use, it was commonly used to power pumps, generators, and milling equipment thanks to its compact size and efficient fuel use. This particular example remains mounted on its original Lister trolley, a factory-built heavy-duty wheeled frame that made the engine portable and versatile. Trolleys like these are now rare and highly prized by collectors. The Junior A23 is air-cooled, built from robust cast iron and known for its simple, durable design. Many still run reliably today with minimal maintenance, reflecting Lister's reputation for long-lasting engineering. Now considered a valuable piece of agricultural heritage, a working 1939 Junior A23 on its original trolley stands as a testament to pre-war British engineering. 1913 Air Motor 8-cycle is a rare stationary engine built by the Air Motor Windmill Company of Chicago. Unlike the company's wind-driven products, this engine was designed to reliably pump water in areas where wind was unreliable, ideal for remote farms and ranches. A key feature is its large front-mounted gear, which connects directly to a pump with 3 adjustable holes. The gear allows customization of the pump stroke to meet different water needs. Its slow, steady speed eliminates the need for extra gearing, simplifying use and maintenance. The engine could power either a pump jack or deep well pump, and once fueled and oiled, it could run unattended for extended periods. Durable, versatile, and efficient, the Air Motor 8-cycle marks an important evolution from wind-only systems to mechanized water pumping, reflecting early 20th century rural innovation. Name: The 1925 IHC McCormick M 1.5 horsepower M is a stationary gasoline engine made by International Harvester under the McCormick brand. Compact and reliable, it was designed for light agricultural and industrial use, powering equipment like corn shellers, pumps, and grinders. It used a Wico-type EK magneto ignition and a throttle governor system for steady, efficient operation. Though small, the engine was dependable and could run for long periods with little oversight, ideal in areas lacking electricity. The M series became iconic in rural America, known for its rugged, simple construction and ease of maintenance. These engines played a key role in the mechanization of farming, bridging the gap between manual labor and motorized equipment. Today, the 1.5 horsepower M is highly valued by collectors and restorers. Preserved in institutions like the Henry Ford, it stands as a symbol of early 20th century agricultural innovation and engineering. The Chore Boy line, built by the Associated Manufacturers Company of Waterloo, Iowa from 1910 to 1924, was a popular series of stationary gasoline engines designed for small-scale agricultural and domestic tasks. These compact engines helped rural households transition from manual or animal labor to mechanized work, powering chores like pumping water, grinding feed, washing, and sawing wood. Typically rated between 1 and 2.5 horsepower, Chore Boy engines featured rugged cast-iron construction and simple hit-and-miss governors for efficiency and durability. Their portable design made them versatile for multiple tasks, and their ease of use appealed to users with minimal mechanical experience. Known for their distinctive green paint, ornate nameplates, and solid flywheels, many were sold with skids or trucks for easy mobility. Advertised as time-saving machines, they provided reliable power in areas lacking electricity or larger equipment. As electrification spread in the 1920s, demand declined, but the Chore Boy remains a symbol of early 20th century rural mechanization. Today, collectors value them for their historical significance and craftsmanship. The Armstrong Sidley AS1 was the company's first axial flow turbojet, developed during Britain's early push into jet propulsion. First run in April 1943, the AS1 served as an experimental platform, giving the company hands-on experience in a field then dominated by centrifugal flow engines like Frank Whittle's designs. Unlike those centrifugal engines, the AS1 used an axial flow layout, offering greater efficiency and future development potential. However, only one prototype was built, and it was never developed further. Despite this, the AS1 laid important groundwork. Its turboprop derivative, the ASP, evolved into the successful Armstrong Sidley Python, which powered the Westland Wyvern strike aircraft. Though the AS1 never entered production, it marked Armstrong Sidley's entry into jet propulsion, paving the way for later turbine engine achievements. The Pratt & Whitney R4360 Wasp Major was one of the most powerful and complex piston engines in aviation history. Developed in the US and first run in 1944, it marked the peak of piston engine design before the jet age. This 28-cylinder, 4-row, air-cooled radial engine displaced 362.5 cubic inches and was nicknamed the corncob due to its spiral cylinder layout. Its semi-helical configuration improved airflow to rear cylinders, reducing cooling problems common in multi-row radials. A mechanically driven supercharger, 6.3741 ratio, enhanced induction, while the propeller gear reduction, 0.3751, kept tip speeds subsonic. Initial models produced 3,000 horsepower, with later versions reaching 300 horsepower using both supercharging and turbocharging, making it the most powerful mass-produced piston engine in the U.S. Despite a solid power-to-weight ratio, about 1.11 horsepower per pound, it weighed up to 3,870 pounds. Between 1944 and 1955, over 600 units were built. It powered aircraft like the Convair B-36, Boeing B-50, Fairchild C-119, Boeing C-97, and Boeing 377 Stratocruiser. However, the engine's complex design led to cooling issues and high maintenance, limiting its commercial success and increasing operating costs. Though quickly eclipsed by jets and turboprops, the R4360 remains a legendary engineering feat, symbolizing the final evolution of piston-powered aviation before the jet era took over. The quick zippers. The 1899 Henriki hot air engine, rated at just 1/60th of a horsepower, showcases late 19th century innovation in small-scale mechanical power. Built in Germany by Gustav Henrici, this precision-made engine was designed for scientific demonstration and educational use. Operating on the Stirling cycle, it used hot air expansion and cooling, unlike steam engines, which required boilers and high pressure. This made it safer, quieter, and ideal for labs and small applications. A modest heat source, like a spirit lamp, was enough to keep it running continuously. Though low in power, it effectively demonstrated thermal to mechanical energy conversion and served as a teaching tool or collector's novelty. Its 1/60th of a horsepower rating reflects its role in showcasing delicate mechanical principles rather than delivering industrial output. Today, surviving Henrici engines are highly valued by collectors, symbolizing the shift from steam to safer, more efficient technologies, a small but significant step in engineering history.